concepts set in stone, experienced identically by everyone. Rather, space and time emerged from Einstein's reworking as malleable constructs whose form and appearance depend on one's state of motion. The development of special relativity immediately set the stage for the second conflict. So that was the first conflict, the conflict between Newtonian mechanics and electromagnetism. So Newton and James Clerk Maxwell. So that's the conflict. Now, they were separated in time, so I don't know how much they were at each other's necks, really, but the theories were in conflict with each other, and they were concluded, or I wouldn't say concluded, but resolved by Einstein's special theory of relativity, which gave us the whole new understanding of light and of space and time and the relative nature of space and time and the constancy of the speed of light that we know and love today. The next thing, the development of special relativity immediately set the stage for the second conflict. One conclusion of Einstein's work is that no object, in fact, no influence or disturbance of any sort, can travel faster than the speed of light. But as we shall discuss in chapter 3, Newton's experimentally successful and intuitively pleasing universal theory of gravitation involves influences that are transmitted over vast distances of space instantaneously. Hello, Professor Nick. It was Einstein again who stepped in and resolved the conflict by offering a new conception of gravity with his 1915 general theory of relativity. So thank goodness this guy has worked also on the general theory of relativity, because the other conflict is really with Newton's theory of gravitation and his own theory of, well, gravitation. But first of all, he worked on relativity generally, or actually, I shouldn't say that. First of all, he worked on relativity specially. His special theory of relativity only worked for inertial frames, and then he generalized it with the general theory of relativity in 1915, 1916, 1917. Those types of years were very crucial for that particular work. So here we are. The whole instantaneous gravitation thing being resolved. Just as special relativity overturned previous conceptions of space and time, so too did general relativity. Not only are space and time influenced by one's state of motion, but they can warp and curve in response to the presence of matter or energy. So once again, not only are space and time influenced by one's state of motion, so space and time are relative depending on your own motion, but also they can warp and curve, warp, W-A-R-P, warp and curve in response to the presence of matter or energy. If there is a very massive body, it warps and curves space-time around it differently than a less massive body. For example, such distortions to the fabric of space and time, as we shall see, transmit the force of gravity from one place to another. Space and time, therefore, can no longer be thought of as an inert backdrop on which the events of the universe play themselves out. So this type of conception of space and time, when space and time can be warped and curved by gravity, by gravitation, by massive bodies, by matter, by energy, then space and time itself is not just an inert background for things to happen in. Space and time itself are intimate players. So once again, this is a very interesting sentence, but I must read it. That's what I say. Time is relative, man. That's why I'm never late. So space and time, therefore, can no longer be thought of as an inert backdrop on which the events of the universe play themselves out. Rather, through special and then general relativity, they are intimate players in the events themselves. So I believe that this sentence will play a big role in string theory, because string theory is